Bismillahirrahmanirrahim. Welcome to FSAC's online sport program. This lecture is for class level 6th to 8th. The video is recorded for class 7th Mathematics week 14. I am Mujahid Raza from Army Public School and College, Ruhe Rawan. Textbook New Secondary Mathematics 2, page number 109 to 114. Unit number 4 Triangles, Quadrilaterals and Polygons. Topic is 4.3 Polygons. Resources required: textbook, notebook and stationery, including protectors. This lecture is to cover a complete review of for week 14. In this week, we have studied polygons and different type of polygons. What are polygons? Polygons are a closed plane figure with three or more straight line segments as its sides is called a polygon. A polygon in which the line segments do not intersect each other internally is called a simple polygon. Simple polygon have furthermore divided into two types, that are convex polygon and concave polygon. Convex polygons are those in which the interior angles of a simple polygon are less than 180 degrees. Then the polygon is called convex polygon. Concave polygon: if any one interior angle, at least one interior angle of a simple polygon is greater than 180 degrees, then the polygon is called concave polygon. In the first lecture, I have given a lot of examples on concave and convex polygon. Here are some examples of polygon with their special names. There are few polygons with their special names also. Number one is three-sided polygon. A three-sided polygon is called a triangle. A four-sided polygon is known as a quadrilateral. A five-sided polygon is called pentagon. A six-sided polygon is called hexagon. A seven-sided polygon is called heptagon. Eight-sided polygon is called octagon. Nine-sided polygon is called nonagon, and 10-sided polygon is called decagon. The example given here in the shape of figures are regular, hexagon, heptagon, octagon, nonagon and decagon. In these figures, the size of the sides may be different from each other, but they will called with their name due to the number of sides. So the polygon having more than 10 sides also have some special names, but these names are difficult to remember. To make it easier to remember, we name them on their number of sides. For example, a polygon having 14 sided sides will be called 14-sided polygon or a 14gon. The next topic is regular polygons. A polygon with all the sides and angles equal in measurement is called regular polygon. In figure 4.13, the first polygon is a three-sided regular polygon. It is called equilateral triangle. The second polygon is a regular quadrilateral. It has four equal sides as well as four equal angles, and we already know that it is a square. The next figure is a five-sided regular polygon. Five-sided polygon is called pentagon, so it is a regular polygon. So it is a regular pentagon. Similarly, the fourth polygon is a six-sided regular polygon. A six-sided polygon is known as hexagon, so it is a regular hexagon. What about the numbers? Is it a regular quadrilateral? The answer is no, because every polygon need to have equal side as well as equal interior angles to be a regular polygon. A rhombus have all the sides equal, but it does not have all the interior angles equal. So a rhombus is not a regular quadrilateral. Second topic was sum of the interior angles of polygons. We have already studied that sum of all the interior angles of a triangle is 180 degrees, and sum of all the interior angle of a quadrilateral are 360 degrees. In this section we are going to study that what is the sum of all the interior angles of the other polygons. To understand this concept, we need to go through the following table. In this table, we are given four sides, four type of polygon. These polygons are triangle, quadrilateral, pentagon, and hexagon. Number of sides are 3, 4, 5, and 6 with respect to the respective polygons. We have also studied this table in the first lecture. The number of triangles formed in the triangle are 1. Number of triangles can be formed inside a quadrilateral is 2. Number of triangles can be formed by joining one vertex to all others in a pentagon are 3. And number of triangles can be formed inside a hexagon are 4. We can observe that the number of triangles formed inside a polygon is always 2 less than the number of sides of respective polygon. Here 4 is 2 less than 6, here 3 is 2 less than 5, here 2 is 2 less than 4, here 1 is 2 less than 3. So this is n minus 2, and n minus 2 is the number of triangles that form inside a triangle by joining its one vertex to all others. The fourth column is representing the sum of interior angles. For that we need to multiply the number of triangles formed inside, that is n minus 2, with 180 degrees. The sum of interior angles of a triangle are 180 degrees. The sum of interior angles of a quadrilateral are 360 degrees. The sum of interior angles of a pentagon is 540 degrees. And the sum of interior angle of a hexagon is 720 degrees. We can find it by multiplying the number of triangles formed inside the polygon with 180 degrees. In the study of above table, we came to know that the sum of interior angle of every polygon is different. We also observe that the method to find the number of interior angles of any polygon is given. It is that we have to multiply the number of possible triangles that can be made inside a polygon with 180 degrees. The formula to find the interior angles of a polygon is n minus 2 multiplied 180 degrees, where n is the number of sides of polygon. Sum of the exterior angle of polygon. As in the previous topic we have studied the sum of interior angles of the polygon, now we have to study the sum of the exterior angle of the polygon. In the figure 4.18, the angle P, Q, R, S and T are the exterior angles of the polygon. The sum of one exterior and interior angle is always 180 degrees. We can see from the figure that angle A plus T, angle B plus P, angle C plus Q, angle D plus R and angle E plus S is always equals to 180 degrees. All of these are equals to 180 degrees. Now by adding all these equations, we get the total of sum of all interior angles plus exterior angles. That is equals to A plus T, B plus P, plus C plus Q, plus D plus R, plus E plus S is equals to 980 degrees. The 900 degrees is the sum of all the right hand sides of all the equations we have written above. Here we know that the sum of interior angles of a pentagon is 5 minus 2 multiplied 180 degrees, that is 540 degrees. So our equation becomes 540 degrees plus sum of all the exterior angle is equal to 900. This 900 was equals to the sum of all the interior and exterior angles. Here 540 degrees is the sum of all the interior angles. Sum of all the interior angles plus exterior angles equals to 900 degrees. To find the sum of all the exterior angles, we need to shift 540 to the right hand side, by which we get 900 degrees minus 540 degrees, that is equals to 360 degrees. So sum of all the exterior angles, that is angle T, P, Q, R and S is equals to 360 degrees. By using the same method, we find that the sum of all the exterior angles of a hexagon, of a heptagon, of an anagon, of an octagon is also 360 degrees. So in general, sum of all the exterior angle of every polygon is 360 degrees. After that, we had solved example 7 from textbook page number 114. In this, we have find the sum of all the interior angles of a decagon. Solution: as we know that a regular decagon has 10 equal sides, so dividing n is equal to 10. As we have the formula to find sum of all the interior angles is equals to n minus 2 multiply 180 degrees. Putting n equals to 10, n minus 2 multiply 180 degrees, that is 8 multiply 180 degrees, which is equals to 1440 degrees. Solving the second part, we have to find the size of each interior angle of a decagon. If it is a decagon, so it will have 10 equal sides, 10 equal angles. There are 10 angles in a decagon, so each angle of decagon will be equals to the sum of all the angles divided by 10. Sum of all the angle is 1440 degrees divided by 10, we can get 144 degrees. That is the interior angle of a decagon. What example 8? This working example is on your textbook page number 119. Part 1. Calculate the number of the sides of a regular polygon with each exterior angle is equals to 224. Solution. As we know that every side has one exterior angle. Also we know that the sum of all the exterior angle is equals to 360 degrees. So the number of exterior angle is 360 degrees divided by 24 degrees, which is equals to 15. As I mentioned earlier that every side has one exterior angle, so the number of sides will also be 15. Part number 2. In this part we have to calculate the number of sides of a regular polygon with each interior angle is equal to 162 degrees. Solution. As we know that the interior and exterior angle sum is equals to 180 degrees, so the exterior angle of the polygon will be 180 minus 162 degrees, that is equals to 18 degrees. So the number of exterior angles is equals to 360 divided by 18 degree, that is equals to 20. So the number of side is also 20, as the number of side and the exterior angle is same, so the number of side of this polygon is also 20. It is a 20-sided polygon. Exercise 4C. Find the sum of the interior angle of the following polygon. Part B is 12 gon. In this question we have to find the sum of interior angle, and that is not difficult. We are doing it again and again, and it is a very simple practice now. The sum of all the interior angles of 12 gon is, putting n equals to 12 in the formula of sum, that is n minus 2 multiplied by 180 degrees. Putting n equals to 12 in this equation, we get 12 minus 2 multiplied by 180 degrees. That is equals to 10 multiplied by 180 degrees, and that is nothing but 1800 degrees. So the sum of all the interior angle of a polygon with the 12 sides is 1800 degrees. The second part is same. In this part we have to find the sum of interior angles of a 20 gon. In the 20 gon, the value of n is equal to 20, and the sum is equal to n minus 2 multiplied by 180 degrees. Putting n equals to 20 in this equation, we get 20 minus 2 multiplied by 180 degrees. That is equals to 18 multiplied by 180 degrees, that is equals to 3240 degrees. The question number 2 from exercise 4C, we have to find the values of unknown from the following. In this part, we are given a pentagon with 5 different interior angles. It is not a regular pentagon. In this pentagon, all of its interior angles have some values. 2 of its interior angles are involving a variable c, and we are asked to find the value of that variable c. Solution. As we know that the sum of interior angle is n minus 2 times 180 degree, as given that this is a pentagon, so n will be put equals to 5. Putting n equals to 5 will get 3 multiplied 180 degrees, that is equals to 540 degrees. By using the formula, we get the sum of all the interior angle, that is equals to 540 degrees. According to the given values of the angle, the equation can be become equals to 101 plus 152 plus 38 plus 2 times c plus 1c is equals to the sum of all the interior angle, that is equals to 540 degrees. We need to calculate the value of c here. To simplify this equation, we need to add all of these angles, that is equals to 291 degrees plus 3 times c is equals to 540 degrees. To get the value of c, we need to shift this 291 degrees to the right hand side. We need to shift this 291 to the right hand side. We get 3c is equals to 540 degrees minus 291 degrees. To get the value of c, we need to divide the equation on the both sides with 3. By dividing both sides of the equation by 3, we get 249 degrees divided by 3 is equals to C. And the value of C is 83 degrees, and it is our required answer. Part D is again the same as we have solved the previous part. In this part we are again given a figure, and this time this figure is a hexagon. It is irregular hexagon with 6 interior angles. 2 of its interior angles are of numerical values, and rest of 4 interior angles are involving a variable D. We have to find the value of that variable D. Solution: we can find the sum of interior angle by two methods, one by using the formula and other by using the given values in the figure. As you know that the sum formula of the sum is sum equals to n minus 2 multiply 180 degrees. The given figure is hexagon, so n is equals to 6. Sum is equal to 6 minus 2 multiply 180 degree, that is equals to 4 multiply 180 degrees, and that is equals to 720 degrees. According to the given values of the angle, the equation will become 108 plus 102, 3 times 4d's plus a 5d is equals to the sum of all the interior angles, that is equals to 720 degrees by formula. By comparing the both sum, we get this equation. After solving this equation, we get 210 degrees plus 17d is equal to 720 degree. To find the value of d, we need to shift this 210 degrees to the right hand side, and we get 17d is equal to 720 minus 210 degrees. To calculate the value of d, we need to solve this equation, and at the end of simplification we get d is equals to 510 divided by 17. Solving this division, we get d equals to 30, which was our required answer. Question number 3 from the exercise 4C. In this question, we have to find the sum of interior angle of a regular hexagon. A regular hexagon has 6 sides and is equal to 6. Sum is equals to n minus 2 multiply 180. Putting n equals to 6, we get 6 minus 2 multiply 180. That is 4 multiply 180 degrees, and that is equals to 720 degrees. We have also to find the size of each interior angle of the same hexagon in the part 2. So the solution is a regular hexagon has 6 sides, and we have already calculated that the sum of the interior angle of this hexagon is 720 degrees. The number of interior angle will be equals to 720 divided by 6, and that will be the size that will be the number of the sides as well. So the each interior angle will be equal to 720 degrees divided by 6, and that is equals to 120 degrees. Dividing the sum of all the interior angles upon the number of angles can give us the size of each interior angle, and that is 120 degree in this question. Part B is similar to the part 1, and students have practiced it themselves. It is also the same question we have attempted in practice session now 7, and the student have to perform it themselves. Question number 4 from exercise 4C. By finding the size of each exterior angle of a regular polygon with 24 sides, each interior angle of a polygon. Solution: as given that it is a regular polygon, so it will have 24 equal sides and angles, exterior and interior angles. As the sum of exterior angles of every polygon is 360 degrees, so its one exterior angle will be equal to sum of all the exterior angle divided by one of its exterior angle. That is 360 degree divided by 24, and the answer is 15. So it will have 15 degrees as its size of each exterior angle. To find each interior angle, we need to subtract this 15 degree from 180 degree. All the exterior angle will be of 15 degree, so each interior angle will be equals to 18 degree. 180 degree minus 15 degrees, that is equals to 165 degrees. Question number 4. Now it is question number 5 from the exercise 4C. In this question, we have to find the size of regular polygon, and we have performed it in the regular lecture number 4. In part A, we have to find the number of sides of a regular polygon of each exterior angle equals to 90 degree. Solution: sum of all the exterior angles of every polygon is 360 degree. It is a regular polygon of exterior angle 90 degrees. As every side has one exterior angle, so the number of sides is equals to 360 divided by 90 degrees, that is equal Question number 5. Find the number of the sides of a regular polygon if each exterior angle is 90 degrees. These questions and with their parts we have performed question number 5 to question number 10 in the previous lecture, lecture number 4. And now we have to revise all these by yourself. These are the question number 7, question number 9, question number 10 and so on. All of these questions are performed in the previous lecture, lecture number 4 and 5. Students have to practice themselves now. At the end of this lecture, I have an assignment for you. Solve the following for your practice. Practice session, practice now 6, practice now 7, practice now 8, page number 114 and page number 119. This is Mujahid Rizza from Army Public School and College, Ruhe Rawan.